This is a lesson for algebra for section 4-3, day 2. What we're talking about today are geometric sequences. Yesterday, we talked about arithmetic sequences where you're adding or subtracting by the same number each time. Today, we're talking about geometric sequences where you're just multiplying by the same number each time. There is no dividing in this. You're just multiplying by the same number each time. So as we talked about yesterday, anytime that you see an A stands for arithmetic sequences. You won't see those today, but what you will see today are the G for geometric sequences. Geometric sequences, you're multiplying by the same number each time. When we see the letter N, that is the term number. So if we are looking for the 20th term in the sequence, N would equal 20. That's sometimes called the index. A sub 1 or G sub 1. You'll see G sub 1 today. That is the first term in the sequence. So whatever number comes first, going from left to right, just like you read a sentence, that is your G sub 1. We're also going to see G sub N today. G sub N is the term that you want. All right, the term that you want. It is the nth term in the sequence. We're not going to see D's today. All right, that's the common difference. That's when you're adding or subtracting by the same number each time. But what we are going to see today is the letter R. R stands for the common ratio. It's what you're multiplying by each time. So for example, if we were doing times 2 times 2 times 2, our R would equal 2. You might have negatives. It could be like times -2 times -2 times -2. But it will be the same number each time. You're never going to have like a times 2 and then times 3 and then times 4. It has to be the same number each time. So yesterday we talked about the explicit formula for arithmetic. Today we're going to talk about the explicit formula for geometric. So for geometric, G sub N is the term that you want. All right. This will give you any number term. For example, if you wanted the 100th term, it can specifically give you that 100th term instead of having to figure them all out by hand. G sub 1. G sub 1, we said, is the first term in the sequence, whatever that first number is, times, and now this is where you have to be careful. Yesterday we had D times N minus 1. This time we have R to the N minus 1 power. That is an exponent. All right, so we have the common ratio, whatever that happens to be. If you're doing times 2 times 2 times 2, it would be a 2 to the N minus 1 power. Remember, to do an exponent on your calculator, you're going to have to use the little caret button. All right, so be very careful here. When we take a look at the first geometric sequence, we have 3, 6, 12, 24, 48. What are we doing each time? Well, to get from 3 to 6, I'm multiplying by 2. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So we're multiplying by 2 each time. Very common question is to find the next 3 numbers in the sequence. So if we keep on multiplying by 2, the next number would be 96. Multiply by 2 again, the next number would be 192. Multiply by 2 again, the next number would be 384. If you can't figure out what you're multiplying by, because sometimes you might have decimals, you might be multiplying by 2.5 or something like that, and that might be a little bit harder to figure out. What you can do, if you realize that it's a geometric sequence, is to figure out your R, you can divide going backwards. You can divide going backwards. For example, 48 divided by 24. Take your two terms, divide going backwards. 48 divided by 24 is 2. 24 divided by 12 is 2. 12 divided by 6 is 2. 6 divided by 3 is 2. Just make sure, be careful, because you're going to have them all mixed up later on in the chapter where you have both arithmetic and geometric. Just make sure that you are getting that same number each time. Otherwise, it's not geometric. Maybe it's arithmetic. All right, be careful. So our G sub 1. Our G sub 1 is our first term, whatever number happens first in the pattern. So this is 3. Our common ratio is what we're multiplying by each time. So that would be the 2. For the explicit formula, I'm only going to write this once. We have G sub n, the term that we want, equals the first term, G sub 1, times r to the n minus 1 power. So when you actually write out the explicit formula for this specific sequence, that you could find the 100th term or 50th term, it's going to be G sub n, the term that we want, equals the first term, which is 3, times your common ratio 2 to the n minus 1 power. So in this one, they want you to find the 12th term. That means n equals 12. You're going to take that n, just like we did yesterday, take that 12, sub it into here for n, and sub it into here for n. So G sub n, which is G sub 12, the term that we want, the 12th term, equals 3 times 2 to the 12 minus 1 power. All right, be very careful. Make sure that minus 1 goes in the exponent, not after the exponent. All right, it goes in the exponent. If you didn't want to do to the 12 minus 1 power, you could also just subtract it by hand and do 3 times 2 to the 11th power. That's perfectly fine to type it into the calculator like that. Just be very, very careful. So in the calculator, you're typing in 3 times 2. Remember, when you type it into the calculator, 3 times 2, caret button, 12 minus 1. All right, be very, very careful like that. Or 3 times 2, caret button, 11. All right, when you do that, you should get an answer of that the G sub 12, the 12th term in the sequence, is 6,144. For the next one, 64, 32, 16, 8, 4. Now, this is where you really, really need to be careful. All right, I can see that my numbers are going down. Well, this is not divided by 2, divided by 2, divided by 2. Is that what we're actually doing? Yes, but remember, geometric sequences are what we are multiplying by each time. It is not what you are dividing by each time. It's what you're multiplying by each time. So when we take a look at this, 64, 32, 16. If you can't figure out what you're multiplying by, divide going backwards. 4 divided by 8 is 0.5. 8 divided by 16, 0.5. 16 divided by 32, 0.5. 32 divided by 64, 0.5. So what we're actually multiplying by is 0.5 each time. So times 0.5, times 0.5, times 0.5, times 0.5. 4 times 0.5 is 2, times 0.5 is 1, times 0.5 is 0.5. So our G sub 1 is our first term. That's going to be 64. Our common ratio is 0.5. Again, be careful. You're not doing 2. Yes, we're dividing by 2, but it's what you multiply by each time. The explicit formula. This is the last time that I'm going to write the whole generic thing. G sub n equals your G sub 1 times your common ratio to the n minus 1 power. So the term that we want, G sub n, equals the first term, 64, times 0.5 to the n minus 1 power. This formula right here will give you any term number that you want. If you wanted the 1000th term, it would be G sub 1000. In this case, we want the 10th term. So n equals 10. G sub 10 equals 64 times 0.5 to the 10 minus 1 power. Again, if you wanted to do to the 9th power, instead, when you type it into your calculator, that is perfectly fine. You get that the G sub 10 is 0.125. In the next one, negative 81, negative 27, negative 9, negative 3, negative 1, negative 1/3. I can tell that my numbers are going down. Anytime that the numbers are going down, you know that you're multiplying by a 0 point something, because that's how the numbers will go down when you're multiplying. Well, if you can't figure it out, divide going backwards. I would start here because they're all the same. -1 divided by -3 is 0.3 repeating. -3 divided by -9 is 0.3 repeating. -9 divided by -27 is 0.3 repeating. -27 divided by -81 is 0.3 repeating. So what I'm really doing is multiplying by 0.3 repeating each time. -1/3 times 0.3 repeating gives you -0.1 repeating times 0.3 repeating is -0.037, 037, 037, 037. So -0.037 repeating times 0.3 repeating. These numbers get really, really small in a hurry. -0.01234567, sort of weird, but that's what it is. Our G sub 1 is our first term, so that's going to be -81. Our value, or sorry, our common ratio is 0.3 repeating, so 0.3 with a little repeating sign above it. The explicit formula, the term that we want, G sub n equals the first term, -81, times the common ratio, 0.333 to the n-1 power. We want the 15th term, so n equals 15. G sub 15 equals -81 times 0.3 repeating to the 15 minus 1 power. Again, if you wanted to use the 14th power, that's fine. Be very careful. When you type this into the calculator, remember 0.3 repeating is really 0.33333333333. Keeps on going on and on and on and on and on and on and on forever. Make sure that you type in at least 10 of those threes into the calculator. If you only type in 0.3, you will get the wrong answer every time. You have to fill up that whole screen with threes. You can't type in too many of them, at least 10 threes. When you hit equals, you get -1.69350878. It's really E -5 on the calculator. All right. When you see E -5, that means it's putting it into scientific notation for you. So 1.69350878 times 10 to the -5th power. That's what that really means. It's too big. It's too small to fit on the screen, which is why they put it in the scientific notation for you. 1/16, 1/4, 1, 4, 16. I would avoid the fractions right away. I would look at your positive numbers there. They're a lot easier to work with. You know that you're multiplying by the same thing every time, so just skip over those fractions. How do you get from 1 to 4 to 16? Well, you're multiplying by 4, multiplying by 4. You couldn't figure that out, divide going backwards. So 16 times 4 is 64. Times 4 is 256. Times 4 is 1024. Our G sub 1 is our first term. All right, that is that 1/16. Our common ratio is what we're multiplying by. That would be the times 4. So I'm going to write 4. The explicit formula, G sub n equals your first term, G sub 1, which is 1/16. You could change that into a decimal as well, times your common ratio of 4 to the n-1 power. You're looking for the 18th term, so n equals 18. So G sub 18 equals 1/16 times, and you could change that into a decimal again, 4 to the 18 minus 1 power, or the 17th power. Type this into your calculator. You get that the G sub 18, the 18th term, when we keep on multiplying by 4, is 1 billion 73,741,824. Big number here. The other kind of question, just like yesterday with the arithmetic sequences, they're going to give you a little description and you have to start writing it, writing the sequence. Write the first 5 terms in the sequence, the explicit formula, and the 30th term. It says that the first term is 8. So our G sub 1 is 8. That is our first term in our sequence. The common ratio is 5. That means R equals 5. That means we are multiplying by 5 each time. So 8 times 5 is 40. 40 times 5 is 200. 200 times 5 is 1,000. 1,000 times 5 is 5,000. The explicit formula, the term that you want, your G sub n equals your first term times your common ratio of 5 to the n minus 1 power. We want the 30th term. So G equals, or sorry, not G equals, but n equals 30. So G sub 30 equals 8 times 5 to the 30 minus 1 power. By the way, I haven't mentioned it yet, but you can't multiply that 8 and 5 together first. Not the way things work. In order of operations, PEMDAS, please excuse my dear Aunt Sally, you have to do exponents first. That's why you could just type it right into the calculator. But if you're trying to do it out by hand, don't do the 8 times 5 first. You have to do 5 to the 29th power first. Anyway, type it into the calculator. And you get that the 30th term in the sequence, again, they put it into scientific notation, 1.49011619 times 10 to the 21st power. It'll say E21. That's really to the 21st power. These numbers get really, really big, really, really quick. All right. That has 21 places. That's too big to fit on your calculator screen. Write the first 5 terms in the sequence, the explicit formula, and the 30th term. The first term is 1/3. So it's 1/3, or you could use 0.3 repeating. The common ratio, all right, so this is your G sub 1. And the common ratio is 9. So R equals 9. That means we are multiplying by 9 each time. So times 9, so 0.3 times 9 is 3. Times 9 is 27. Times 9 is 243. Times 9 is 2,187. The explicit formula, the term that we want, G sub n equals your first term. You could put 1/3 or you could put 0.3 repeating, either way, times your common ratio of 9 to the n minus 1 power, right? Either of these 2 answers that says n minus 1 are perfectly fine. The 30th term, so n equals 30. Now think of how quickly this is going to get bigger and bigger and bigger if we're multiplying by 9. So G sub 30 equals our 1/3 or 0.3 repeating times 9 to the 30 minus 1 power. Again, you could use the 29th power if you wanted to. 1/3 times 9 to the 29th power, the G sub 30 or the 30th term in our sequence. Big, huge number, 1.570042899 times 10 to the 27th power. Again, 27 digits, 28 digits is way too big to fit on the screen. Again, just as a quick little reminder, if you can't figure out what the R is, what your common ratio is, divide the numbers by going backwards, all right? To find your R, divide the numbers going backwards if you can't figure out what you're multiplying by.